What does symmetry mean? Right, the same on both sides, like a mirror image. We have three different types of symmetries. For example, this is the function x squared. If I put 2 inside there, what's my y value going to be? If I put this is my x-axis. If I put x in the S2, what's my y going to be? Yeah, because you put 2 squared is 4. Remember, y is the same thing as f of x. If I put -2 inside there, what's my y value? Very good. So this function is symmetric about the y-axis. It's symmetric about the y-axis. Remember, here's the y. This is the x. So it's the same on both sides. How do I test it? F of x and f of -x were the same answers. If I plug in the same value for x, except just change the signs, and it gives me the same answer, then it's reflected, it's symmetric about the y-axis. We call that an even function. The second one, we say is symmetric about the x-axis. In other words, it's this equation where it's plus or minus in front of it. So it's y equals plus or minus square root of x. That's what that one says. But this is how it looks. Because if x is 4, what values of y can give me that same value? If x is 4, what squared will give me 4 as an answer? +2 and -2. Or likewise, plus or minus the square root of 4 is equal to the plus or minus 2. Is this a function? Which one? Vertical line. I think I said horizontal. Yeah, it doesn't pass doesn't pass the vertical line test, so it's not a function. But we do have objects like right here. This is called a hyperbola. Those exist. So do circles, but they're not functions. And then we have functions that look like this. This function is the cube root of x. It is a function. It is symmetric about the origin. Because if x equaled 8, what does y equal? What's the cube root of 8? 2. Plus 2 times 2 times 2 is 8. Likewise, if I had f of 8, the cube root of 8 is 2. If I change to negative 8, the cube root of negative 8 is negative 2. We call this an odd function. So when we talk about symmetry, we also talk about reflections. So if it's symmetric about the y-axis, it's reflected about the y-axis. It's a mirror image. Same thing here. If it's symmetric about the x-axis, that means it's reflected across the x-axis. This is, you could say that reflected across the y-axis. We can say reflected across the x-axis. And then this is reflected across the origin. So all we're doing here is we're checking different values of x. The same numbers, just positive and negative. So that's how we're going to be testing these things. Even functions or odd functions. If it's not even or odd, it's neither. An even function is if you place the same values but different signs inside there. and you get the same answer. An odd function is if you place a negative inside the function, you get the negative of the original function. Again, this one's symmetric about the y-axis. This is symmetric about the origin. Example 1. Y equals x squared plus 2. Test symmetry for that. Is it symmetric about the x, y, or origin? Y-axis first. And we'll test the x-axis. And we'll test for the origin. This equals 2 and -2. So if we have 2 squared plus 2, 4 plus 2 is 6. Then we put a -2 in there. -2 squared is 4. So the answers are the same whether I put positive, negatives. What does that tell me? It's symmetric about the y-axis because I changed the x, and therefore it's an even function. Is it symmetric about the x-axis? Again, pick two numbers, positive and negative. Two squared plus 2, 4 plus 2. -2 squared plus 2. Is this symmetric about the x-axis? What should happen if it's symmetric about the x-axis? But what would the numbers look like? Let's look at the pictures. If it's symmetric about the y-axis, it looks like this. Symmetric about the x-axis, it looks like this. So we have the points. So this point looks like -2, 4. This is +2, 4. What do we notice about that one? Different x's, same y. That's symmetric about the y-axis. This one is 4, 2, 4, -2. What do we notice about these 2 points? So x gives you a positive and negative y value. So do I keep the same x value and get different y's? No. I got the same y's for different x's. So it's not symmetric about the x-axis. And the origin. We use the same two values. We know that's going to equal 6. We know that's going to equal 6. So what do we notice about the x-axis? I mean, around the origin. This point is 8, 2. This point is -8, -2. Yeah, so we go from whereas if the x change signs, so do the y. In other words, it goes from xy to -x, -y. This one goes from xy to x -y. This one goes from xy to -xy. That's what you're looking for at 2 points of the curve. So that function, all we can tell about it is an even function. Let's look at example 2. X squared plus y to the 4th equal 5. We have to look for the x-axis, the y-axis, and the origin. So how do we do that? What do you have to do first? Get the y by itself. Exactly. Very good. So we have to solve for y. We get y to the 4th equals -x squared plus 5. And then take the 4th root of both sides. So y is equal to plus or minus the 4th root of -x squared plus 5. So we'll try something easy. 1 and -1. Now it's positive and negative. Let's look at the positive side. So we put -1 squared plus 5. -1 plus 5. It's the 4th root of 4. Now we put it in the same one in the negative. negative 1 squared plus 5. It's positive 1. Negative 1 plus 5. You see, okay, I'm going to have 4 different ones, but I have to try it both for positive and negative. I have to try both of these. And so see what happens. So these are for x equals positive 1. One's positive, one's negative. Now I'm going to put a negative 1 inside there. Negative 1 plus 5. Negative side. And these two were for the x equals negative 1. So what do we know about these answers? Is this symmetric about the x-axis? How do you know? Well, yes, because it's going to be, well, when x is 1, the y value is that. When x is negative 1, the y value is that. When x is 1, it's this and this. So it is symmetric about the x-axis. Is it symmetric about the y-axis? Put the same values in there. So when x changes from positive to negative, we get the same values. Let's look how this graph is. It'll give you a better idea of what we're looking at. So we have x squared plus y to the 4th equals 5. It's like an oval. So any point you pick here is going to have a mirror point here. So it's symmetric about the x-axis. It's symmetric about the y-axis. It's symmetric about the origin. So we'll get the same values for all of these. So that's what it's always going to look like. It's going to, in other words, they should have given you a circle. X squared plus y squared equals 4. So you see exactly it's always symmetric everywhere you look at. But this is an example of this type of picture. So in this example, this function is symmetric about the x-axis, it's symmetric about the y-axis, and it's symmetric about the origin because we get the same values. That was a pretty tough one. Example 3. Determine if the functions are odd or even. I'm going to give you a shortcut here. Oop, this is 7. Minus 6x cubed minus 2x. I'm going to give you a shortcut here. Even functions can only have even powers and or a constant. Remember, even functions are symmetric about the y-axis. So if it's symmetric about the y-axis, we know we have something like this. This is x squared. The power is an even number. Or what if we had a constant function, which is a horizontal line? It's symmetric about the y-axis. So even functions can only have even powers and constants, or it doesn't have to have constant numbers. Odd functions are symmetric about the origin, can only have odd exponents. No constant. Again, odd functions can only have odd exponents and cannot have constants. Even functions can only have even exponents, and they can have, or they don't have to have a constant number. So with these two examples, is the top one odd, even, or neither? Is this an odd number? Is this an odd number? What number is there? Is that an odd number? So this is odd. There are no constant there. All the exponents, there are no even exponents. There are no even exponents, no constants, so therefore it's an odd function. Yes, the number, the solid number. How about the second one? Odd, even, or neither? It has even exponents and a constant. This is even. No, if it's even, like I said over here, if it's an odd, if it's an even exponent, or if it's a constant number, this is y equals some number, k. It's symmetric about the y-axis. So even exponents, even functions can have even powers and or a constant. Odd, even, or neither? Which one? Even. Very good. Good. All my pens are dying. So that's the end of that section. That's all there is to it. Odd, even functions. Traditionally, they're expecting us to give you a whole big spiel about calculating, doing the plus and minus numbers. No, this is all you have to look for. You don't have to test anything.